numbers below the set should be right there. Be these numbers. That's 75% of my numbers. Okay, if I said, what percentage of my numbers were above 51? Well, above 51 would be here. So 25% of my numbers were above 51. If I said, what's the range of my set? The range would be the highest number minus the lowest number. If I said, what's the inner quartile range? That would be the highest quartile minus the lowest quartile. Okay. All right. So what I want you to do now is I want you to go ahead and see if you can create a box plot based on the gold medals. Okay, so you would want to write those numbers out, which I already did in numerical order. So I already took care of that for you. So what I need you to find is the median, the Q1, and the Q3. And then also you need to find the lowest value and the greatest value, but that's easy to find. I'll give you about 5 minutes. I gotta step away from my computer for about a minute, so. Hi, is Ava here? Ava. Do is we have to kind of block out the other side.
I'm here.
Hey Madison, how you doing today?
I'm good.
So Madison, if we look at these numbers in this set, the median's the number in the middle. What'd you get for the median?
$15.
15, good. So if you guys don't understand how she got 15, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 numbers. That's 500. So that means we have 2 numbers in the middle. So the average of 15 and 15 would just be 15. So that's my median. Now to find the quartiles, Q1 and Q3, what we have to do is we have to kind of block out the other side along with the median. And we find the middle number of those. Well, the middle number of those is easy. It's 20. If the median is the middle, then that means it's going to be the same position number on each side. So the middle number on the other side would be 11. So guys, that's pretty much our box. Our box starts at 11, middle of our box is 15, and the right side of our box is 20. So this goes from 9 to 44. So I'm going to make a number line that goes maybe, let's go multiples of 10. So we have 10, 20, 30, 40. So the middle of my box is at 15. That's easy. That's directly between 10 and 20. 11 is the left side of my box, which will be just above 10. 20 is the right side of my box. We extend out to 44. We extend to 9. Okay. Any questions on that box and whisker plot that we just did before we go to the next one? And numbers. A book. Something we've talked about so far is how to make a box plot. Now what we're going to start talking about is how to determine if something is an outlier. The other day we talked about outliers. We said outliers are numbers that kind of don't compare with the other numbers. They're kind of far away from the other numbers. Well, they have to be actually a certain distance to do that. In order to find the outliers, we have to use something called the interquartile range, the IQR. Okay, so this is the definition of what an outlier is. Okay, this is from a book. Sometimes when you read it from a book, it might not make much sense, so I'm going to kind of explain it for you as well. Okay, so if we distribute numbers by extreme values that differ greatly from the other observations, these extreme values are called outliers. That sounds kind of nerdy. It sounds kind of hard to understand. Okay, so basically what that means is if we have a number that's greatly different from the other numbers, it's called an outlier. Now, how do you tell if something's an outlier? You basically use the interquartile range. And if the interquartile range, if you multiply it by 1.5, if the distance is greater than that number, then it's an outlier. Okay? So here's what I mean. Whatever your Q1 is, okay, and remember, when you look at a box plot, this is the Q1, this is the Q3, the number in here and here. This part of the box and this part of the box. So let me explain how we do this. All right. So what we want to first figure out is what's our Q1 and Q. So 11 and 80, are these outliers? Okay. Most people would say yes, because they're on each end. But they have to be a certain distance. Okay, and here's how you find it. You take whatever your Q3 minus Q1 is. Whatever that answer is, you multiply times 1.5. If the distance is greater than that, then it's definitely an outlier. So here's what we mean. Let's first figure out what our Q1 and Q3 are. Well, in order to find Q1 and Q3, we have to figure out our median. So actually, let me put these in numerical order so it's easier for us. So this should be 32, and this should be 33. Sorry about that. Okay. So what's our median? Our median is our middle number. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our middle number would be between those two. So we would say 30. Now we cover up this side. Whoops. We cover up this side and the median. The middle number here is 33. The middle number over here would be 16. So Q3 minus Q1, 33 minus 16 is what, 17? And what's 17 times 1.5? It's 25.5. So what that means is if I add 25.5, if I add that with 30, with 33, I get 58.5. So what that means is anything above 58.5 is an outlier. Well, 80 is above 58.5, so it's an outlier. Now, also, if I subtract these, I get 1.5, which is 25.5. If I take 25.5 and subtract it from 16, I get negative 9.5. So that means any number that's smaller than negative 9.5 would be an outlier. Well, 11 isn't smaller than negative 9.5, so it's not an outlier. Okay. We only have a few slides left, guys. I think we have 2 slides left. Okay, and then I'll give you guys your assignment for today. All right. This is 25%. And you can put your answer in the chat. What percentage of data values are greater than 60 on this chart? What percentage are greater than 60 on this chart? Sorry. Good job, Saeed. Good job, Sandra. So it should be an answer that kind of comes quick to you if you're paying close attention. You may have missed this in the lesson today. Remember, we said that each of these sections, right, a box plot is cut into 4 sections. So that means each section is 25%. So this is 25%. This is 25%. This is 25%. And this is 25%. Even though it's not balanced, it's not evenly drawn, that means 25% of my numbers fall between 40 and 60. 25% of my numbers fall between 60 and, what was that, around 70 something? So if the question is, how many are greater than 60? Well, here's 60. The box plot only goes here after 60, so that would be 25%. If I said what are less than 60, well, less than 60 would be here. So that would be 25 plus 25 plus 25. So guys, you're really not doing a lot of, you don't have to figure out the percentages. The percentages are cut into 4 groups. So as long as you know how to add and subtract by multiples of 25, you'll be good. 25 plus 25 plus 25 plus 25. Okay. So your assignment, okay, is to log into Delta Math and to do Delta 2, D2, okay.